Welcome to the first lecture of statistics. Today we are going to talk about the topic central tendency. In this class, we will give a theoretical overview as well as a more practical view of statistics. In particular, in this class, we will talk about theoretical concepts of central tendency, showing you the general idea and mathematical formulas as well as demonstrating these concepts in Excel and in Python. So let's start with the theory. Many people talk about central tendency and start talking directly about the mean, the median, and the mode. However, there are more measures of central tendency. The mean, mode, and median are in fact the three most famous, but there are others. Have you ever heard about the harmonic mean, for example? I list here some of the measures, some of which are less known, but not less important. So, for example, geometric mean, weighted mean, truncated mean, interquartile mean, hinge mean, median range, tree mean, Wien-Scissorized mean, and harmonic mean. Although these measures have their uses, today we will focus on the three most used measures: the mean, the median, and the mode. So, it is important to start by understanding what it means and finding out what central tendency is. It can be said that the central tendency is the single central value around which the data most often lies. Several measures or metrics try to capture this trend, this typical value, in the best way. Some measures work better in certain contexts than others. Let's see this better with an example. Let's observe the central trend of the ages of the Portuguese soccer team. Here we have the first 11 players called up from the Portuguese team for the Portugal against Slovakia game on October 13, 2023. Each player has an age. For example, Diogo Costa, the selected goalkeeper, is 24 years old. Cristiano Ronaldo is already 39 years old. In this context, what is the typical age? What is the central age tendency of a Portuguese national team player? We can use the mean to try to answer this question. How to calculate the mean? Here we have this formula. The result from the average is nothing more than the sum of the individual values x of y, in which I varies between 1 and the total number of elements, which is then divided by the number n, the total number of elements. In other words, the average is nothing more than the sum of values divided by the number of elements. In our case, it will be the sum of all ages of the 11 players divided by the number of players. The result of this count is approximately 27. The typical age of a player in the national team is around this value. But what if there are extreme values? If we record very large or very small amounts in our data? Does the average formula still work as well? Let's see this with an example. Imagine that we were interested not in the average age, but in the average market value. We have various market values between 15 million Cristiano Ronaldo's and 90 million Rafael Leão's value. Now, imagine that Ronaldo's market value was not so low as 15 million, but 400 million. It is an extreme value because it is different from other values. In this case, it is much larger. It could be smaller, to be extreme. But let's analyze two scenarios. In the first scenario, in which Ronaldo is worth 15 million, we have an average market value of 55 millions, a realistic value. However, in the other scenario of 400 million, we have an average of approximately 90 million, which is very high and reflects the extreme value of 400 million. 90 million is not at all what we expected for average market value. When there are very extreme values in the data, it is concluded that in these cases the best measure of central tendency may not be the mean. This is because it will not give us the central value, or the typical value if you want, as we needed. Another measure that also makes sense, especially when we deal with extreme values, is the median. The median is the value that divides the dataset into two equal parts, with half of the values above it and half below it. The median of a dataset X varies according to the number of elements in the set, n. If n is even, then we have to sort the data and select the two middle elements, and then take the average between the two. If n is odd, it is simpler. Just select the middle value. Let's go back to the example of market values with extreme values. In this scenario, Ronaldo has 400 million market value. We order the players by their market value from smallest to largest. Then we find the middle value. Remember, the number of elements is odd, so that's why we can do this. We want the value that divides the dataset. This value is 60, much more reasonable than the average of 90 million. Note that Cristiano Ronaldo's market value can increase as much as you want, 400 upwards, but the mean will remain the same. Finally, we need to talk about the mode. The mode is the least used measure of central tendency, but it is a useful measure in certain situations. It represents the most common value in a dataset, that is, the value that appears most frequently. In the case of our team, the age value that appears more often is 24 and 29 years old. To find the mode, simply count how many times each value appears and choose the value that appears more frequently. If two or more values appear with the same maximum frequency, then the dataset has two or more modes. In the case of our example, we had two modes. Here we have an Excel with data in three columns: first column, second column, third column. In the first column, we have names of disciplines. In the second column, we have Maggie grades for each of the disciplines. Similarly, in the third column, we have Flanders grades. The first thing that we want to do is to calculate the mean. To do so, we first need to call function average and pass it the range of grades of Maggie so that the average grades of Maggie is calculated. Next, we can do the same for Flanders grades. Flanders' average grade is higher than Maggie's average grade. Let's see what the median is. We can call the median function and pass the same range as before. We can do the same for Flanders. Call the function median, select the range. That's it. Again, the median is higher for Flanders than for Maggie. We can calculate the grade, the most common value that Maggie had for grade. So we can write mode and give it the same range of data, and we obtain 14. What about Flanders? Flanders, we calculate the mode as being 20. Okay, so in all respects, the mean, the median, and the mode, Flanders had better or higher scores. Following the practical exercise in Excel, we now have another example in Python. So the first thing that we want to do is import the necessary packages such as NumPy. And in this case, we will also use SciPy stats subpackage. So we need data. The first thing is to put the data inside a vector. And we can put 1, 12, 23, 43, 100, 9. This is just random data, numerical data. The thing that we can do now is calculate the mean. So we call NumPy mean of the vector. And this we put in a variable called mean of the vector. Okay? And we can print it. We can print mean of the vector. Let's just put a label before. Mean of the vector is blah blah blah. Mean of the vector. Here I have the wrong parentheses. And now I can run my code to discover the mean of my data. And the mean of the vector is 31 something. Nice. So now we can calculate the median also and see what we have here. So we print the median of the vector is median vector. Let's run it. And now we have 17.5. We can calculate the mode using the package SciPy. In this case, we'll call the subpackage stats. And we pass the vector. This will give us the mode of the vector, which you can also print. And now we have our three measures. Let's see them. So we have one mode, count 1, and the mode equals to 1. So the most frequent element is the first. Thank you for watching and see you next video.